Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll discuss a concept of draft tube and its type. Along with this, also we'll discuss about the application of draft tube and what are the advantages and disadvantages of draft tube. Also we'll discuss. First thing we'll see what is the working principle and what is the construction of this draft tube. Let's see. So draft tube is a pipe which is gradually increasing area and in which one end is connected to the outlet of the runner and one end is connected to the outlet of the runner and other end is submerged in the water below the level of water in the tail race. Okay, we know that if any kind of pipe or it may be in different shapes, we have like two ends will be there, one end and another one is another end. Suppose if I consider any of the draft tube here, this is one end is there and this is another end is there. So one end will be connected, this will be connected to the turbine outlet of the turbine. You can say outlet of the runner or outlet of the turbine also. So this end and this end, suppose this is one end, entry part of the draft tube. So this end will be connected to the outlet of the runner. We know that basically this will be used in the reaction turbine. So when there will be a pressure difference in the reaction turbine and there is a problem of existing of water, so there we used to use this draft tube. Okay, we'll discuss about that also. So one end is connected to outlet of the runner and another end, this end, the other end, the outlet part is which is below the tail race level. Like this is, suppose tail race level is there, so below this level this will be kept here, and this is actually used for discharging the water from the exhaust of turbine. What I told you that when the water will be come out from the turbine through the runner at outside, so this draft tube will be helps there to discharge the water from the turbine to the tail race. So when the, suppose here if you connect the turbine part, so the turbine part outlet is here, that is the inlet for draft tube, and this will help that water to go outside to discharge the water from turbine to outside. And what is the function of this? We can say this maintains the subatmospheric pressure to increase the performance of the turbine. So here actually there is, as I told you, that there is a low in pressure inside this runner when the water will be come out from the runner, so it will try to helps to increase the pressure. And what is the function of this? The draft tube will convert the high velocity of kinetic energy into pressure energy, and also it minimizes the losses at the exhaust of turbine, and also you can say it will prevent the backflow from the tail race. It won't be that water won't go back from the tail race to inside. So how it is functioning means, if you know the function of the turbine, reaction turbine specially, then we can easily understand why this draft will be required for that. Actually, when the water will be exist from the turbine, suppose this is the turbine is there, and in this turbine we have like a number of blades will be there and that will be connected to a runner. So when the water will be come out from here, this is the, suppose inlet is there, like you can say the casing part is there and this is dam is there. From the dam the water is to come out and it is to goes inside to the turbine. So in the turbine we know that many parts are there, components are there, like a runner will be there, blades will be there, covering like casing will be there, and guide mechanism is there. So when the water is striking this well and after coming out from here, this, there will be a difference of pressure. There will be a difference of pressure in the runner. So before, before striking, the pressure used to normal pressure used to there, or high pressure used to there, you can say. And when it's striking this blade, so the guide blade will be maintained, or the guide will be helped this water to increase its velocity, or we can say control the velocity of fluid. So the pressure will be converted to kinetic energy, or you can say the velocity. So here your high velocity will be there, and due to that the pressure started decreasing. So your velocity increasing and pressure here decreasing inside the runner part. So when it's striking and completed that part, the rotation part is completed and the shaft will be started rotating, then it will be connected to the generator, your electricity will be produced. But when it's the time comes for existing from the runner, at that time, as I told you, that pressure already reduced. So with a low pressure, it cannot able to come out from the turbine to atmosphere, because atmospheric pressure level is there. And here the pressure which is created, where which is formed, that is lower than the atmospheric pressure. So it is very difficult to come out from from a position from low pressure to high pressure. It is difficult. So what will happen? So to maintain this pressure level, the runner outlet pressure and the atmospheric pressure level, we used to connect the draft tube. Okay, so that in the draft tube, what will happen? As I told you, that it is gradual increasing area. So with this increasing area, we can say here velocity started decreasing. Area increases here. If I say here area increased, if area increased, our velocity will be decreased. We know the formula, like Q equal to AV. So area increased, velocity decreased. Similarly, our pressure also started increasing here. Okay, from the low pressure to, it will start increasing the pressure level, that will be high pressure, or that will be equal to the atmospheric pressure level also. Okay, either it will be should be equal or it should be more than that, so that the water can easily exist from the turbine outlet to throw this draft tube to outside. So that's why it should be within the tail race level. That's why it is given. It minimizes the energy losses at the turbine exit. If this part is not there, then the velocity, the high velocity of fluid, okay, it will be directly existing to the outside. So the kinetic energy total is going to loss. Even the pressure is less, so there will be a backflow will be started, or that water won't come outside here. So there will be a problem. Energy losses will be there at the exit of the turbine. That's why to prevent this kind of things, there are draft tubes used. Now here, there are different types of draft tubes are there. Basically, these four types I have considered. One is conical draft tube, second one is simple elbow draft tube, third one is Moody spray draft tube, and the last one is the draft tube with circular inlet and rectangular outlet. So these are the four types of draft tube what I have taken from the book. So first one, if you see the conical draft tube, mostly you used to use the conical draft tube, which is in, it is a structure of frustum of a cone. If you see, a cone will be like this. Okay, a cone, if you see the cone, the base will be like circular will be there, and this will be like triangle type structure will be there. If you cut a portion, like that is called frustum, if you cut a portion from the part here, then we can see this kind of structure. That is nothing but this one, the conical draft tube. And here it is in vertical, it will be vertically placed. The conical draft tube will be placed vertically. And here, if you can say that diameter is very, very small, and obviously your diameter is slightly more than the inlet condenser, and the flow direction will be straight, and divergent will be there, and the angle, you can see this is conical because some angle is there in the cone. If you see, this is a vertical line, this is the vertical line, then some angle is there. So the cone angle for this angle is mostly 8 to 10 degree. Okay, the angle of this tube, and the efficiency used to give provided by maximum efficiency by this conical draft tube, near about, we can say that is 90%, maximum 90% of efficiency can be provided by the draft tube. And this is prepared, or this is made of different materials can be used, but specially we used to use the mild steel. We used to use the mild steel plates will be used for prepare the conical draft tube. Similarly, the second one, simple elbow draft tube. If you see the simple elbow draft tube, here also we have a bent, it will be bent in structure. Elbow type will be there. Elbow mostly some angle will be there between inlet and outlet position, and that elbow position will be near about 90 degrees to given. But here it is given slightly some angle given. It can be taken up to 90 degrees because the name itself given a simple elbow draft tube. So here also same thing, as I told you, that at inlet condition we have diameter circular in structure, and slowly that area will be increased here, and this will connect to the turbine runner end, and mostly it can be used for Francis turbine. See, in the A reaction turbine, what are the most examples are there? We have Francis turbine, Kaplan turbine, and propeller turbine. So in mostly all these draft tubes will be used for either Francis turbine or we can say Kaplan turbine. And the shape of this, as I told you, that is airborne structure, and this can be also used in the Kaplan turbine, Francis turbine or Kaplan turbine, both we can use. And this draft tube can be used for the low head position. Low head, as this is Kaplan turbine can be used, so it can be used for the low head position. For Francis turbine also, if you see, that is medium head will be there. Okay, this is the concept of simple elbow. The next one is Moody spreading draft tube. This is the example of Moody spreading draft tube. Here slightly different. This can be used, this will be used, we can say, for Kaplan turbine, suppose, and the efficiency will be near about, yeah, here actually for the simple tube, elbow tube efficiency is slightly less, that up to 60% efficiency will be there for this, not that much high, but here if you get like more than near about 90% is there. And here for the Moody spreading draft tube, we have like one entry will be there, but two exits, multiple exits is there. So the structure is here, inlet part will be circular, part will be there, but outer part will be divergent, two divergents are there like this. So here this can be used for the Kaplan turbine, and its efficiency will be near about 88% is there. And it's divided into two parts, like two divergents are there, as I told you. So in this draft tube, actually its main aim is to reduce the swelling in motion, that when the water will be come out from here, the runner part, so it will be try to avoid the swelling in motion in the water. And this can be also used in the low head condition. And if you use this draft tube for the Francis turbine, then that time we can use this medium head position. Okay. Yeah, the last one is the draft tube with a circular inlet and rectangular outlet. So here is simple, like inlet is our circular part, but outlet, if you see, that is a rectangular outlet is there. So this is slightly different. So this kind of draft tube will be designed for different flow conditions, different flow conditions it can be used. And the rectangular outlet is given to increase the efficiency, okay, by changing its shape. Like here its shape is circular, but here the shape is rectangular. So this kind of draft tube was designed for special conditions and to increase the efficiency also. And the flow will be like smooth flow will be there through this, and through the area it will be slightly like, you know, the pressure will be changed and the velocity will be decreased. Anyway, same thing will be there. At the outlet we can see the expansion will be there and energy conversions will be also there. So this also can be used in different areas, like hydropower applications, and also different head also you can use this. Different head also we can use this. So these are the some like different types of draft tubes are there. And next one we'll discuss about the applications. So applications of this draft tube in many places, as I told you, that especially we are using for in the draft reaction turbine outlet. So that can be used in the hydroelectric power plants, dams, pumped storage system, water treatment plant, then marine applications, and for turbine design also it is essential role will be there. So these are the some applications of draft tubes are there. We'll see some advantages and disadvantages about this. So draft tube, obviously it will increase the efficiency, this is correct, and prevents backflow from the turbine. Already I told you in the first starting, this will be prevent the backflow from the tailrace, and also it will enhance the energy conversion, like kinetic energy to pressure energy. And also this will be optimal for low head turbine applications, because it cannot be used for the high head. This will be always used in low head or medium head, and will be prevent for cavitations and blade damage. Obviously it will try to because when cavitation will be formed, when there will be a pressure difference is more, and that backfire will be there, so it will try to avoid the pressure difference and like try to avoid the cavitation especially, and pressure recovery, and that will be reduce of velocity at the exit of water, same thing, and reduction of energy losses in the turbulence. Okay, and it also flexible in design, for different kind of turbines also. Yeah, as I told you that different types of draft tubes are there based on the applications, you can use that. Similarly, it is a long-term and cost effectiveness and the facilities for the utilization of available heads and power generation. So these are the some advantages of draft tube. Similarly, along with there's also some disadvantages also there. So we'll see that initially the cost will be a little bit more. So that was considered the disadvantages. Initial capital cost is more. And risk of cavitation, as I told you that cavitation is the prevention of cavitation. But if the design is like somehow complicated, then there is a risk of cavitation is there, not for all the cases. And similarly, increase in that space, obviously space requirement will be more when you are trying to avoid the pressure difference and cavitation. Obviously, we need to install some different parts in that, which will be increase in space requirement. And potential head losses due to the friction. Obviously, when there will be flow in the pipe, there will be a friction. Friction, there will be head loss will be there. And always you need to do some maintenance and inspection for all these challenges. And the flow disturbances in complex designs. Simple design means there is no issue, no problem will be there. But if when it is coming to the complex design, obviously we will have some disturbances in the flow. And potential flow for suppressor and hydraulic instability. Next, the limited usefulness for the high head. Obviously, it cannot be used for the high head. Environmental impact concerns in the large systems. So there is environmental issues in this point is there for large kind of systems, not a small one. So these are the some disadvantages are there, which I have taken from the different sources, and whichever is easy to you to remember, you can easily remember these things, or advantages and disadvantages. So I hope you understand this theory of draft tube and its types, its functions and applications, advantages, disadvantages. Still, if you are having any kind of doubt and inquiry regarding this problem is here, you can give a comment on the comment box. Thank you all.